friends, today we will discuss about ruby laser. Depending on the state of matter of the active medium of laser, we are having different types of laser, that is solid state laser, liquid state laser, gas laser, fiber laser and semiconductor laser. In the previous unit we have already discussed about semiconductor laser. Today we will be discussing few of the lasers which are there in your syllabus. So we will be discussing about ruby laser, carbon dioxide laser and helium neon laser. Out of these three, ruby laser is a solid state laser and carbon dioxide laser and helium neon laser, these two are of gas laser. So today we will be discussing about ruby laser. So what is this ruby laser? Ruby laser is a 3-level solid state pulsed laser. From here you can see it is clearly mentioned that this is a 3-level laser, that means 3 energy levels are involved in the process of the lasing action. Further, it is a solid state laser because the active medium is in the form of solid, and this is also a pulsed laser, that means the output is not continuous, rather it is pulsed in nature. In ruby laser, the synthetic ruby crystal is used as laser medium. It is the first successful laser developed by Mayman in the year 1960. It produces visible light, that is red light of wavelength 694.3 nanometer. Here I have mentioned that synthetic ruby crystal is used as the active medium or laser medium. What is this ruby crystal? This is nothing but aluminum oxide crystal which is doped with 0.05 to 0.5% of chromium atoms. So basically it is an aluminum oxide and that is doped with 0.05 to 0.5% of chromium atoms. And because of this doping, we are getting the color of ruby crystal varies from pink to red. If doping is less, then it is more towards pink color, and as we are increasing the amount of doping, it will become red in color. So depending on the amount of chromium, the ruby crystal appears pink to red in color. Now coming to construction of ruby laser, this is basically a ruby rod, and the length of this rod is about 4 centimeter and the diameter is about 1 centimeter. So this is in the form of a cylinder, and this is the active medium for ruby laser. So first of all we are taking this ruby rod whose length is about 4 centimeter and diameter is about 1 centimeter. Okay. Further, the two faces over here, these are the two end faces, right? So these two faces are grounded and polished such that they are parallel to each other and perpendicular to axis of the rod. So these two faces are grounded and polished, they are parallel to each other and also they are perpendicular to the axis of the rod. If I am taking this xy as the axis, then these two faces are perpendicular, right? Further, both the faces are silvered to serve as optical resonator. So these two faces are silvered so that photons can get reflected from these two faces, and while they are moving through this ruby rod, because of this multiple reflections, they will produce lot of photons that we will discuss under working of ruby laser. Okay, so these two end faces, they serve as optical resonator. Out of these two faces, the rear face is totally reflecting, whereas front face is partially reflecting in nature. So this is the rear face and this is the front face. This rear face is totally reflecting in nature, whereas this front face is partially reflecting in nature, so that we are getting the output from this front face. Now this rod is surrounded by a helical flash lamp which is filled with xenon. So this is the ruby rod and this is the helical flash lamp which is filled with xenon. So this ruby rod is surrounded by this helical flash lamp. And this helical flash lamp is connected to a power supply. This is the power supply and this is the key over here through which we can switch on and switch off the laser. Okay. So whenever we are switching on this key over here, this power will be supplied to the helical flash lamp and white lights are produced. So the flash lamp produces flashes of white light whenever activated by the power supply. Further, these white lights, they helps in pumping, and that is why we are getting a optical pumping system in case of ruby laser. So as I told, when the circuit is switched on, flash of light is obtained around the ruby rod. So when we are switching this on, we are getting flashes of light over here. It is coming from all direction. So these lights are coming towards ruby rod. Further, the lights which are going in outward direction, there is a reflector surrounding this. So when they will strike this reflector, they will come back towards this ruby rod. So the arrangement is made in such a way that whatever this light are being emitted from this flash light, they will be directed towards this ruby rod. So when these lights are hitting this ruby rod, what will they do? They will pump the chromium ions from lower energy band to higher energy band. Thus, as these chromium ions are pumped by using this light energy, that means optical pumping takes place in case of ruby laser. Now let us understand this working through energy band diagram. So basically there are three energy levels involved. This is E1 is the ground state, E3 is the pump state and E2 is the metastable state. And initially most of the chromium ions, they lies in the lower energy state, that is E1, and very few are there in the excited states E2 and E3. So when we are switching on the device, the flash lights are produced, and because of those flash lights, these chromium ions which are sitting at the lower energy states, they are excited to the pump state. So these are moving to the pump state. Okay. So transitions takes place from E1 to E3 due to optical pumping, and this optical pumping is happening because of the flash light produced in the helical flash lamp, right? Once the ions reach the pump state E3, they cannot stay here for longer time because the lifetime is very less in this pump state. So after a certain time, they will start moving towards E2. Okay, and few of them will also move to E1. So this is moving to E3 and after some time it is coming down to E1. Okay, so after a short period they fall into the metastable state E2 through non-radiative transition. So most of the ions which are moving from E1 to E3, they will make a transition from E3 to E2. Okay, and this transition is non-radiative in nature. Here let me mention that the lifetime of metastable state E2 is much greater than the lifetime of the pump state. So the ions, they can stay at E2 for a much longer time as compared to the time they can stay at E3. At E2 they can stay up to 10 to the power minus 3 second, but as far as this E3 level is concerned, the lifetime here is up the order of 10 to the power minus 8 second. So when these atoms are moving from E1 to E3 and coming to E2, they are staying there for a long time. So after some time, what will happen? They are getting accumulated at the energy state or the metastable state E2. So slowly they are getting accumulated at E2. So accumulation takes place at the energy state E2. So when they are getting accumulated over here and these are getting formed from E1 to E3, so time will come when we will get more number of ions getting accumulated at E2 as compared to E1. So if you will compare these two energy states E1 and E2, we can see that population inversion is achieved, and this is the condition to be satisfied for lasing action. So let us move to the next step. So when this population inversion is achieved, let one of these atom is moving automatically or spontaneously to energy state E1 after the elapse of the lifetime. Okay. So when this ion is moving from E2 to E1, it will emit a photon. Okay. Because this transition which is taking place from E2 to E1, that is radiative in nature. So this photon is being emitted by the ion when it is moving from E2 to E1. So a chance photon is produced due to spontaneous emission from E2 to E1. Now what this photon will do? This photon will trigger one of the excited ions which are sitting at energy state E2. So when this photon is hitting some or triggering some ions which are sitting at E2, then stimulated emission will take place. So this ion is moving from E2 to E1 because of the stimulation by this photon. Okay, so this is stimulated emission. So when this ion is moving from E2 to E1, it is again emitting one photon. So this photon triggers another excited ions and leads to stimulated emission, and because of this emission we are getting one more photon. Now we are having two photons. These two photons, they will trigger two more ions at energy state E2 and we will be getting 4 photons. Like that the process will continue and we will be getting a high intense output. So this is the ruby rod. Let this first photon is produced over here. So this is the photon which is obtained through spontaneous emission. Okay, so when one photon is or a chance photon is produced due to spontaneous emission, this photon that will move within this ruby rod. So when this photon is moving, so it is hitting this face, and as I told, this face is totally reflecting, this is partially reflecting. So when this photon hits this face, that will be reflected back towards the rear face. So it is moving towards the rear face. From here again it will get reflected and it will move towards the front face. Okay, so the photons produced within the laser medium bounce back and forth between the two end faces. So whatever photons are produced within this ruby rod, they will move inside this rod and they will bounce back and forth between these two faces. So when they are moving within the rod, they will hit the ions which are at the energy state E2. So if one photon is hitting another ion, we are getting two photon. These two photon, when they will hit two more ions, we will be getting four photons. That way the number of photons will get multiplied. Okay, and finally we are getting the output through this partially reflecting phase. So this is the laser output. Thus, the amplified high intense light escapes through the partially reflecting end to produce laser output. So, it is coming through the partially reflecting phase. This phase is totally reflecting. So, this is partially reflecting. That's what part of the photons are being transmitted through this phase, and this is our laser output. Further, the wavelength of the emerging light is 694.3 nanometer or 6943 angstrom, which corresponds to red light, and that is the energy difference between these two energy states, that is E2 and E1, and this difference is nothing but 694.3 nanometer. So this is our output, which is red in color. But what happens when ions are moving from E2 to E1? After some time, we'll see that the population at E2 is becoming less as compared to the population at E1. That means the population inversion is not existing anymore. And once the population inversion is not there, we will not be getting any output. And again it will take some more time to make these to pump these ions from E1 to E3, and they will reach at E2 such that again we will be getting the population inversion. So up to that time there will be no output coming out from this laser, okay, and that is why we are getting a pulsed output. So initially there was no population inversions, the output was 0. So once the population inversion is achieved, we are getting the output, but after some time the population inversion is violated and again the output is becoming 0. Again it will take some time to get the population inversion re-established and to get the output. That is how we are getting a pulsed output in case of a ruby laser. So let us summarize the salient features of ruby laser. It is a 3-level solid state pulsed laser. Ruby rod is the active medium and chromium ions are the active centers for lasing action. Optical pumping occurs through light from flash lamp. End faces of the ruby rod are silvered, which serve as optical resonator. So these things you may get in short type questions. What type of pumping occurs in case of ruby laser, and what are the parts of ruby laser which acts as optical resonator. The wavelength of the emerging light is 694.3 nanometer or 6943 angstrom, that is red light, okay. You may get fill in the blanks type questions over here. If it is asked in nanometer, you write it as 694.3. If it is asked in angstrom, then it is 6943 angstrom. Further, ruby laser has very high output power of the order of 10 to the power 4 to 10 to the power 6 watts, but the efficiency is low. So these are some of the salient features of ruby laser. Today we will stop here. In the next class, I shall discuss about carbon dioxide laser. If you like the content, please press the like button and share the link with your friends, and also do subscribe to my channel. Thank you all.